Assalamualaikum. Today video we will like to present our mini project for subject BMFR3523, which is CAD CAM. We are from group 29 and we are decided to create customized impeller for this project. Okay, our group consists of 4 members, which is AMIRUL NASRI bin NASRI, Muhammad NURAZRA'E bin AZHAR, Mior Hafiz bin Mior ABDUL LATIF, and SYAZWAN bin AZIZUDDIN. Okay, for introduction, computer-aided design CAD and computer-aided manufacturing CAM are two industrial computer programs frequently interdependent, which have considerably affected the process chain between the original design and the final product production. In this study, we choose to make customized impeller, which then we required to design 3D model of the product. This mini project is conducted to test our abilities to apply the fundamental principle of CAD CAM to 2D drawing, 3D models, surface modeling, and CAM work. The main objective conducting this project, first, to probe student understanding and capabilities in applying the basic principle of CAD CAM, that in creating 2D sketches, 3D models, surface modeling, and CAM operation. Second, to design 3D model using CATIA part design module, generate detailed drafting of mechanical part, and apply principle of CAD in creating 2D sketches and 3D model. Third, to perform simulation on machining operation and produce part programming for this operation with the detail of cutting time and other necessary detail. Okay, for the team member job scope, AMIRUL NASRI will focus on designing, which is he need to draw the product that fulfill the requirement in CATIA software, while Muhammad NURAZRA'E will focus analyzing the design and generate the drafting. After that, Mior Hafiz will work on the simulation, which is to generate the simulation for machining process and NC code. Finally, SYAZWAN will take the responsible on the documentation and editing. He will prepare the project report and edit the presentation video. This is the Gantt chart for our customized impeller project. After the task given by the lecturer, we finalized the selection of product on week 8. For chapter 1, we only needed 1 week to finish, while for the chapter 2, regarding the part design of the project, which is crucial part, we take almost 2 weeks to finish. For chapter 3, simulation part, we take 2 weeks to finish, which is week 12 and 13. Then, for chapter 4, which is drafting, we only take 1 week to finish, and we finish it right after the simulation part done. Finally, for chapter 5, discussion, completing the report and prepare the presentation video, we completed in week 14. And the submission will be on week 15.
Next, I will explain the procedure to create the 3D model. The product of this project is customized impeller, as it designed following the requirement for the project. So first, entering the part design mode to do the drawing of the impeller. Select the XY plane and click on sketch. Draw a circle from center axis and drag it to get the radius into 160 mm. And if it's done, click on the AZ workbench and perform a padding on the circle for the impeller base. Its padding length, set it into 20 mm. Double check the pad by clicking the preview button, and when done, click OK. And then on top of the body surface, again, sketch a circle with 40 mm its radius for the shaft body. When done, exit workbench and perform a padding again with 20 mm length. This will complete the second section pad from the body of the impeller. Continue the second section pad and click sketch on it, and again sketch a circle with 20 mm radius from the center axis. Do not forget to sketch another rectangular on the circle for the key slot. Here, the dimensions are according to the key size of the certain shaft. Trim the excessive line like this. When done, exit workbench and perform a pocket with up to last type. To review it, click preview and OK if it is OK. Next, continue to the chamfer the second section pad body. Click on this line to chamfer it and set the length 20 mm. It's done, click OK. Again, on the same body, perform a fillet on this line set the radius with 20 mm, click preview, and if it's done, click OK. Okay then, let's start creating the blade for the impeller and select the top surface of the impeller body. Do 2 circles from the center axis, start off with 160 mm radius for the outer layer and one more with 80 mm radius inner layer for the blade. And then continue with creating the arc at any point for the center with 130 mm radius. Guide it to intersect the outer and inner, and one more arc at the center with 140 mm radius. After that, click trim button to trim the excessive line, so the blade is sketched up with nicely done. Then, exit the workbench, pad the blade with 30 mm height, and select the blade sketch to perform it, and if it's done, click OK. So now, the blade supposedly has 6 pieces on the impeller. So, do the circular pattern for the blade to make it 6 pieces. Select the body to pattern and set it into 6 and 60 degrees for the angular spacing. For the reference element, click on the surface that wanted to pattern the blade. Then, create hole in between the blade. Adjust the positioning of the hole at the place wanted. Set the hole up to last together with the diameter 30 mm. Click preview, and if it's done, click OK. And again, do the circular pattern for the hole, as the hole also need have 6 in number on the impeller. Again, same reference for the hole. Set it up with 6 and 60 degrees for the angular spacing, same as the blade. So last part to design for the impeller. Create the shell on the edge of the blade. To do it, select the face to remove all together, and then other thickness faces need to be selected also, each of it. As our impeller, the shell inside thickness set up with 2 mm, while outer just make it 0 mm. If it's done, click OK. So here are the customized impeller with complete design.
Now I want to explain the machining process and the simulation for this project. For creating rough stock, first go to Start, select Shape and choose Generative Shape Design. Select a rough stock and insert the height of the rough stock. For safety plane, set the top plane as the safety plane of the product. To start machining process, select Start, select Machining and choose Advanced Machining. Double click at Part Operation. To set up machine 5 axis, select 5 axis machine. Choose Tool Sample 01. Choose Tip and Contact. OK. And choose pptable sample.pptable. Now for reference axis, choose any plane axis and select reference plane of the product. For design part setup, double click part body. For stock setup, double click at rough stock part. And for safety plane setup, select the safety plane that has been set up. For first machining, select facing. Then select the plane for the facing process, which is side plane or drive plane, rough stock plane and top plane. Then set the tool for facing process and the direction of cut and tool path style, and now we can simulate the facing process. Then select profile contouring for profile process. Select the plane for the profile process, which is side plane, top plane and bottom plane. Set the tool for profile, the direction of cut and tool path style, and then we can simulate the profile process. Next, select pocket for pocket process. Select the plane for the pocket process, which is top plane, side plane, bottom plane and island plane. Use the same tool, direction of cut and tool path style, then simulate the pocket process. Now using facing process for the second floor, select the plane for the facing process, then set the tool for the facing, the direction of cut and tool path style, and then run the simulation for the facing process on the second floor. Next, select isoparametric machining for fillet process. Set the tool for fillet. Then, select the plane and direction of cut for the fillet process. And then, set the tool path style and machining tolerance. And then we can run the simulation for the fillet process. Next, also use isoparametric machining for chamfer process. Select the plane and the direction of cut for the chamfer process. Set the tool for chamfer. Set the tool path style and machining tolerance. And then we can run the simulation for the chamfer process. Next is the step for blade shell using profile process. Select the plane for the first shell process, which is the bottom, side and top plane. Then set the tool for the shell process. Then set the direction of cut, type of counter and tool path style, and then we can run the simulation for the shell process for the first blade. Next is for second blade shell by using the profile process. Select the plane for the second shell process. And by using the same parameter of tool and cutting method, run the simulation for second shell process. After done second blade shell, now we can proceed to the third shell. By using the same parameter and same top plane and bottom plane of second blade shell, we can copy the parameter of the second blade shell into the other's blade shell. The difference of the parameter are only on the side or guide plane. Then after done, change the parameter of the third shell, fourth shell, fifth shell and sixth shell. Now we can run the simulation for the all 6 blade shell. Next is drill process. Use spot drill to do the marking for ease the drilling process. Set the depth and the diameter of the hole. Set the point for the all 7 holes they provide on the product. Then set the jump distance of the tool. Set the approach clearance for the tool and the application of the tools. Set the tool parameter of the spot drill, and then we can run the simulation for the spot drill process. Next is the drill for the 6 hole of the side product. First, select the point at the side hole which is contains 6 holes of the product. Select the jump distance for the tools. Set the depth and diameter of the holes, and then set the tool parameter. And then set the parameter for the drilling holes. Then we can run the simulation for the side hole drilling process. Next is to drill the center hole. Select the point for the hole, and then set the depth, cut and diameter for the hole, and then set the jump distance for the tools. Set the parameter of the drilling tools, and then set the parameter for the drilling of the hole. Then we can run the simulation for the drilling process at the center hole. Next, use the pocket to generate the slot process. Select the plane for the slot process, which is the top plane, side plane and guide plane. We can remove the island plane. Then offset on bottom, set in -2 mm to ensure the bottom is fully cut. Set the tool path style and direction of cut. Set the tool parameter for the slot process, and we can run the simulation for the slot process. Last step is finishing process. By using profile contouring process, set the plane for the process, which is top, guide and bottom plane. Then set the tool path style and direction of cut. Set 5 mm for distance between path and set 14 for number of path. Set the parameter of the finishing tool, and then we can run the simulation for the finishing process. To generate NC code, select Tools, Option and set NC for the extension. And then, go to Manufacturing Process, choose Generate NC code interactively, set NC code as NC data type and choose Cinemeric 840D createx.pp for post-processor file, then execute it. Check the file where we save the document. And now the NC code is ready.
Now we go to drafting part. Entering the drafting mode, click the Start, select Mechanical Design and select the drafting. Modify the format of paper, select A4 ISO, then the drafting paper will appear. After the paper appear, click Front View, click Window on the toolbar and select the part design. Identify and click the front view of the product. Right click and select the properties. Adjust the scale that suits the draft paper. After that, generate the top view and the side view. Adjust the location of each view. Then, generate the isometric view from the part design. Right click and adjust the scale of the isometric view. The resolution of the isometric view also can be customized. Now, adjust the location of all the view. The dimension can be generated manually by click the dimensioning command. Can choose any of part that want to generate the dimension. The dimensioning command can measure the radius, diameter, straight line or angle. After completing the dimension, click Edit on the toolbar, select Shape Background. Select the frame and title block to generate it, then apply. After that, edit the title of the drawing, name and others. The size of the text also can be customized. After that, go back on working view. Now for sectional drafting. Front view generated from the part design and generate the sectional view by click the offset section and align section. This is how the section line are created. After that, detail view also projected to show the critical part. Adjust the location of all the view. So this is the result for detailed drafting and sectional drafting. Now we go to discussion part. For designing the part design, consists of various processes such as sketching, adding and removing. Circle command commonly used as the design of the impeller itself are circular shape. Then, pad, pattern and shell is the example of command in adding process being used in this project. The example of command in removing process are pocket, hole, chamfer and fillet. The most difficult part while completing the project was the blade of the impeller. The blade required a lot of commands such as it need to choose the correct angle while sketching. It also need to pad with desired dimension that suitable with the whole part. The blade requires to be patterned into 6 equal shapes with the guide of angle. It needs to be shell to make it like the desired design. However, all the difficulties have been succeeded as desired by do it step by step and following how more experienced people did in CATIA. For simulation of the machining process, rough stock need to create as a raw material and guider for the facing process. The first process carry out with the facing to run as removing the top plane of the rough stock. The next process is profile contouring with used to generate the yearly shape of the product. Isoperimetric process is then one of the process is used in this project to create fillet and chamfered shape. Pocket process also taking part in this project. Next process included in this project is drilling process that require 2 tools, which are spot drill tool and drill tool. One of the most difficulties is selecting the tools for each process. Each process has different size of tool according to the design specification. Two other part needs to take account is the selection of the command, where the command is include tool path style, direction of cut, machining tolerance and the selection of the cutting plane. The selection of the command needs to precisely and logic. It can be solved by trying it one by one and study the use of each command that involved in the process, so that the project will be easy to complete.
Okay, for the conclusion, we can conclude that for this project CAD/CAM, which is aimed to assess our ability to use the fundamental CAD/CAM concept to develop 2D drawing, 3D model, surface modeling, and CAM operation is achieved. As we choose customized impeller as the product for this project, and the part design required in this project is fulfilled through this product. From this project, we also learn on how to design 3D model using CATIA component design module. Hence, this project exposed us to create the mechanical part in detail and use the main CAD to produce 2D drawing and 3D models. Since CAD/CAM is important for designing in engineering field, so throughout this project, students will get an early exposure to the realities of the real working environment. Finally, CAD/CAM software enable us to directly to combine the turning and milling equipment with CNC.